Really, if you ask me, the truth is simple. You don't need a PhD, you don't need a math background or years of coding experience. By the end of this journey, you will understand technology at a conceptual level. You will definitely know how artificial intelligence makes decisions, why weights are very important, and how change of these weights also makes a big meaning in this whole journey. Also, these weights are fixed, bias is fixed. Therefore, you keep, you know, asking the same question, you're always going to get the same answer. My attempt is to translate the world of technology into a language that people can understand, especially with some relatable examples, some stories, so that it all makes everything familiar for you. As I always feel that nothing is complex. Most of us see technology from the outside. We hear a lot of buzzwords, and sometimes we say to ourselves, this is all too much for me. This is my answer to the whisper that you have in your heart. I'm going to call the series as the uninitiated series. It's going to be a guided path for anyone who's curious, but always feels unprepared, overwhelmed, or simply new. You always tell yourself, I'm not the seasoned engineer, I'm not the academic researcher. And I think I'm also the same. I'm just an everyday learner who wants to understand slowly, clearly, and without fear. Really, if you ask me, the truth is simple. You don't need a PhD, you don't need a math background or years of coding experience. All I'm asking you is just bring a pinch of curiosity. My attempt is to translate the world of technology into a language that people can understand, especially with some relatable examples, some stories, so that it all makes everything familiar for you. As I always feel that nothing is complex, it's only unfamiliar. Now, I'm calling this series as uninitiated. It doesn't mean that it's for people who are uninterested, and it definitely does not mean unintelligent. It simply means someone who has not yet been introduced to a subject but is willing to learn, is willing to be open, and is willing to be ready. In every field, there's a threshold moment, right? When the outsider becomes the insider. When you feel that, okay, as an outsider, I did not understand any of the concepts. And later you become the insider and think, hang on, I understand everything clearly. And I feel this series is your threshold. Definitely, I'm not going to drown you on things like linear algebra, probability, and calculus. Of course, we need to touch base on those, but we're going to try and do everything through stories, through some life experiences, through some intuition. By the end of the journey, this is my promise to you. By the end of this journey, you will understand technology at a conceptual level. You will definitely know how artificial intelligence makes decisions, understand why technology works the way it does, gain confidence, feel like a member of the technical conversations that you would be participating in. So, no fear, no gatekeeping, no complexity for the sake of complexity, just learning in the most humanly possible way. Keep the knowledge accessible, keep the knowledge clear. And in particular, we're going to talk about a series of AI stuff. I just wanted to help you understand how machines think. Because if you ever looked at artificial intelligence from the outside, I think for most of us, we feel a little intimidated. If that's the case, then this series is going to be for you. And I'm going to call it AI for the uninitiated. It's my attempt to take you gently step by step through ideas that shape the modern AI with minimal max, with minimal jargon, and without assuming anything other than curiosity. So, this is for all of us who come to AI from different paths, some coming from technical background, some from creative background, some from philosophical background. But yet at the heart, we still have a one simple question: how machines learn. And to answer that, we're going to start with the first session today, which is going to be the very interesting session, the smallest unit of computation in the AI world. That is the neuron. That is what we're going to talk about today. I welcome you all for this first session and hope it's a great journey for all of us, including me. And I'm grateful and I'm thankful that I'm doing quite a lot of learning because of you listening to me. I really appreciate you taking your time and listening to me. Let's begin. Welcome to the first recording on artificial intelligence in English. Today we're going to talk about one of the fundamental concepts called the neuron. And it's going to be our first series in English where we're going to uncover some of the AI concepts. We're going to keep it as simple as possible, as grounded as possible, without any jargons. We're not going to assume anything. We're just going to hope that you just bring the curiosity to the table and I bring the concepts and keep it easy for you. Back in 1943, two researchers, Warren McCulloch and Walter Pitts, they were trying to understand how the brain works. They were not trying to create a modern AI or anything like that. They were just trying to explore how the brain works. And they were wondering, could they really mimic that for computers? And in turn, paved the way for creating of the simplest model of a neuron. When you look at a neuron, there's going to be few things that's going to be there. A neuron is going to take some input and it's going to add them. Usually it's going to add them together. To keep it very simple, we're just going to keep it as addition. And then it's going to compare it to a threshold. We got a threshold. And finally, if the sum crosses the threshold, then we are going to do some particular actions. It's a very simple model, takes an input, adds them together, compares the total, and if the total reaches some particular threshold, then we are going to be good. What will happen if the input is going to cross the threshold? Then it's a success story. Let me add the success because it has crossed the threshold. And otherwise, it's going to be a failure. It's really simple. Let's take some inputs. Let's take three inputs, x1, x2, x3, and we add them, which is technically x1 plus x2 plus x3. And we're going to just compare it with the threshold, a made-up number, and we are just going to say, okay, if it has crossed that threshold, then we are happy, and otherwise, we are not happy. Now, this is the model that both McCulloch and Pitts were suggesting, and it's really interesting to know that form the basis of all the modern AI concepts, even the ones that are in practice today. Let's dive a bit into the input. Let's say we got an input, x1, x2, x3. These are the inputs that we have got. And obviously, the sum is going to be technically x1 plus x2 plus x3. That's pretty easy. Finally, we have a threshold, which is t. And your output really depends whether the sum is greater than or equal to t. I'm just keeping it as simple as possible. Let's take some values. Let's quickly look at that. Let's say x1 is 0, x2 is 0, and x3 is 0. All we have got is 0 plus 0 plus 0. And let's say the t is a made-up number. Let's say it's 3. all we are doing is, okay, the sum is technically 0. Therefore, it is 0 greater than or equal to 3, which is technically false. Right. Now, you can always denote false mathematically or in the computer world as 0. Okay, let's go to the extreme and let's do another example where it's not 0, 0, 0, but it's, let's say, 1, 1, 1. What we're going to have is 1 plus 1. It's 3. Sum is 3. We are simply comparing, is 3 greater than or equal to 3? Yes, 3 is equal to 3. Therefore, the output is true. And there you go. We got the output as 1. It's an interesting observation that you would find with 0, 0, you would get the result as false, whereas with 1, 1, 1, you get the result as true. Now, if you put everything in a table, this is what you're going to see. This is the table that you've got. And this table is quite interesting because this table tells you that what we have built is nothing but an AND gate or an AND logic. This neuron, the addition and the threshold, we have picked in such a way that we have performed an AND gate or an AND operation from a Boolean point of view, from a Boolean arithmetic point of view. Choosing a different threshold, a different check or a different operation, comparison operation, you could probably build an OR gate. This was the fundamental aspect that really kicked in for all the modern AI concepts. Now, you might be wondering, what has this got to do with the modern AI concepts? Before even we get in there, let's take this one step further. Let's make this example much more personal, much more interesting for us. Let's talk about how you make a decision. I have a question to myself. I'm going to ask myself, I need to learn the deeper concepts of AI. And one question that I have myself is, should I really spend some time and money on it, or should I not? Imagine I walk into a room where there are few groups of people. Let's say I've got some family members, I've got some close friends, and I've got some AI experts. There are 3 sets of people in the room, and I'm going to ask this question. What's the question? The question is, I need to learn deeper AI concepts. And who am I asking to? I'm asking to some of my family members. I'm going to ask it to my friends. And I'm also going to ask to my AI experts. Before even you get into the nuances of this problem, I want to highlight one key important aspect. The aspect is you automatically process these opinions differently. For example, your family members probably has a bigger weightage, or you respect their words more, their words hit deeper, and your friends probably know your personality. Probably you would give a different weightage to them. And experts know the technical reality of things. Probably they will be talking with confidence. Depending on their voice, you could be swayed between your decision. This is what probably will run in your mind. When the family tells you something, you may think they know best, so probably I should listen to them. And when your friends speak to you, you might say, oh, they get my vibe, but I'm not going to really bother about them. And also, experts, depending on their voice, sometimes you might be excited, sometimes you might be scared. And their influence could even be negative. This is where it's quite interesting. You're not treating the information the same way, although the information could be quite similar. Everybody could say no, or everybody could say yes, but you may not take it in a particular way. And interestingly, even before anyone tells you or even anyone talks, right, before even you get into the room, you come with your own prejudice, that is your own bias. You're going to be biased. Sometimes you're going to say, okay, before anyone talks, I'm going to probably say yes. We are going to see, for such a scenario, if I am replaced by a neuron, how this emotional vetting happens. A neuron is going to do what I would do in the real world. I'm going to make a decision based on real feedbacks from real people. I do have bias for each of them because each one influences me very differently. And also, I have a bias towards the entire topic because I'm really keen to go and do it. Therefore, I'm already coming into the scenario with a bias. So let's break it down. In real life, you could argue that some opinions count more, some count less, and some count negatively. And also, you have your own prejudice. Your bias value shifts the final decision. That is going to be, again, a key point. That is, sometimes just because you're biased, you might probably say yes to something that should have been a no. Now, from a modern AI concepts, we are now going to introduce, apart from input, we are going to introduce something called as weights, and we are going to introduce something called as bias. So we now have, apart from our input, apart from our threshold, we are going to have all these with us. What do we have? We have inputs, we have weights, we have bias, and we have threshold, and we have the sum, and also finally the check. Really, what is new here is the weight and the bias are something new that we have really brought in. What is this weights? As I mentioned, this is what like I'm going to be influenced, right? Family has got a much bigger say in my decisions. Their influence is going to be high. I already come with a bias, so I come with a preconceived notion of what the outcome should be, although I would still go and listen to everyone. This is where it is going to be very interesting. It is no more just the input threshold, sum, and check, but we have added now weight and bias. Why all these matters is that when we understand how this is all put together, then you would understand how AI does the decision, how it's still simple and still powerful, why weights are very important, and how change of these weights also makes a big meaning in this whole journey. Also, these weights are fixed, these biases fixed. Therefore, you keep, asking the same question, you're always going to get the same answer. Therefore, the whole neuron is fixed. The learning aspect was really missing during the early days. But given that for our problem statement where I'm going to make a decision, but I have some preconceived notion, which is a bias, and different people influence me differently, therefore they've got weights. Now, my sum is going to become very different. It's not just x1 plus x2 plus x3, but rather it's going to be something more than that. Let's look at that purely from a diagrammatic point of view. When you look at the whole thing again purely from a diagrammatic point of view, this is what you would see, that I've got x1, x2, x3, but I also have now w1, w2, w3, which are weights. And I've got a bias, which is b. And therefore, my entire function is not adding x1 plus x2 plus x3. The real value of the input is no more just mere x1 and x2 and x3, but the input along with the weight gives me the real value. Therefore, just considering merely the x1 is not going to be useful for my purposes. I need to now consider, instead of x1, I need to consider x1 times w1, and the same way x2 times w2, and x3 times w3. Therefore, I need to put them together and add them to the bias and then apply the threshold. Therefore, if you're going to put it in a nice little formula, then this is how the formula is going to be. You got the input. The input pretty much gets applied to the weight, and then you add all the weighted input. That's called the weighted sum. And that in turn is added with the bias, and the output is checked with the threshold. That's a threshold check. Sometimes we call it as activation. I want to solidify the concept here. We're going to run through some numbers, but I want to keep it as simple as possible. As we said, every group member has got a different influence on my question. Family has got a heavy influence or a heavy impact. friends probably have a moderate impact, and expert, it really depends. This is what I'm going to do. I'm going to give each group some kind of a number. Let's start with family. The family, I'm going to give them a number 2 because they've got a heavy impact. And for friends, I'm going to give probably number 1 because they have a moderate impact on my decisions. And although they're experts, and I'm not sure because they have some kind of a negative impact for me, I'm going to give them -1 because sometimes, really depending on their voice and really depending on what they're saying, I might not choose them. And also, even before anybody talks about it, I have a bias. Let's say I have a heavy bias towards yes, I'm going to have the bias as 3. So you can see here now, instead of just talking about concepts here, instead of talking about influence, we have brought in some mathematical number. So the family is 2, and the friends is 1, and the experts is -1. Now, just to keep it easy for everyone, so this is going to be my W1, and this is going to be my W2, and this is going to be my W3. Now the bias, I'm going to call it as B. Let's look at the formula that we were talking about. And we said it's nothing but, we said X1 times W1. Let's say it's X1 times W1. And let's say the next one is X2 times W2 and X3 times W3. We effectively add all of them together. That's what we have done so far. And what we do is we finally add the bias. That's the B. This is going to be your sum. Now, apart from that, everything remains the same because we are going to compare the sum with the threshold. Is sum greater than or equal to T? And depending on that, it's either output is either a 0 or a 1, which is true or false. Output could be either 0, output is either 0 or 1. As you can see here, the mathematical formula is nothing but x1 times x2 and x2 times w2, and it's x3 times w3 effectively added with bias. Let's look at this. Let's look at this from a mathematical table point of view. It's going to be an interesting find. I've showed you all the possibilities there. The possibilities of everybody saying no and everybody saying yes and everything in between. Look at the 4th row where the friends have said yes, but both the family and the experts have said no. Although that's a no, because I've got a heavy bias and my bias is 3, I'm always hitting my threshold, which is 4. Therefore, I'm always going to be saying yes to it. Or rather, when one friend says yes, I'm going to say, okay, I'm going to go and choose it. This is an interesting take on things where even one friend encourages, I'm going to just say yes. I'm very biased. Because of my bias, even with one yes, I'm always probably going to go and do it. That's the idea of the modern neuron, where the whole idea has been borrowed from the simplified neuron, which McCulloch and Pitts formed in 1943. And one thing I want you to understand is that the whole idea of weights and the whole idea of bias is all fixed. This neuron is never going to learn. It is simply going to perform the computation, and it is simply going to give you the output, but it is really not going to do any kind of learning here. Whereas in our next session, we are going to talk about how this whole thing can be made dynamic or becomes dynamic. Therefore, the weights and the bias changes. As the weight and the bias changes, that becomes the next major step in the history of AI. And therefore, it enables neurons to learn. And therefore, it brings us a whole lot of opportunity. Thanks for your time. It's been wonderful talking to you. It's my first attempt to have this session. We're calling this session as the uninitiated series, where someone who has not been introduced to a subject but is ready and curious to begin. This series is my way of holding the door open for you. And thanks again. This is JW signing off from you. Thank you.